Hello there, Advanced Math. We've been talking about expressions for a long time now, and we're going to kind of transition our way to talking about equations. And so today's going to be our day we kind of talk about both. So next page is variable equations, which are when two expressions are equal to each other. So please write this as your title for the next day. Once you have done so, close your math notebook, unpause, and concentrate with me. So quick reminder, sort of our pre-middle school level, equations are things that have equal signs in them, things like 2 plus 5 equals 7. That's an equation. And this equation involves two expressions. 2 plus 5 by itself is an expression. And believe it or not, 7 is an expression. And since this expression and this expression are equal, I can make them into an equation by just saying, well, this is an expression, and this is an expression, and since I know that this expression equals this expression, I put an equal sign between them. So that's super kind of low elementary level stuff. We have been for a while dealing with expressions like, here's an expression. And today we're going to start transitioning into turning expressions into equations. Alright, so here we go. I'm going to do 2 today instead of just 1, just to kind of practice with you. So we're going to make an equation today for this situation. And I'll show you how it's going to work. So, Madison bought 4 fancy water bottles. Azila bought 2 fancy sporks. They both spent the same amount of money. Write an equation that shows this situation. So in this problem, the way I think about this is I really have, if I think back to all the time we spent doing expressions, I really have 2 expressions here. I have expression number 1 that involves Madison's water bottle, or her 4 fancy water bottles, excuse me. So she bought 4 fancy water bottles. We're talking about money, and I find out later they spent the same amount of money, right? So expression number 1 is however much money Madison spent. I guess that's 4, I'll call it F for fancy water bottle. And that's all I know. I don't know how much they cost. I don't know how much 1 cost, and I don't know how much 4 cost. So the best I can do to represent this is 4 times however much, this cost. Okay? And so Azila bought 2 fancy sporks. I love a good fancy spork. I have lots of them. And I don't know how much those cost either. And I also don't know how much money she spent or how much 1 was. All I know is she bought 2 of them and they cost some amount of money. So that's a separate expression. I know 1 expression for Madison's amount of money. And I know Azila bought 2 fancy sporks. I already used F. So how about if I'll go and do my F. How about, since they're both fancy, I don't want to say, I can't say this. I can't use F to be the price of the fancy water bottle and the fancy spork, because that makes it seem like they're the same unknown value, and I don't know if they are. So I can't do that. So why don't we do water bottle and S. If you use an S, you just got to be real careful to make sure it doesn't look like a 5. It's kind of easy to make them look like 5s. It's one of the variables we don't use very often because of that. So I got expression number 1 and expression number 2, and I have this wording in here that tells me that I can make them into an equation. They spent the same amount of money. So however much these were and however much these were, they are equal to each other. So I can make an equation by taking this expression and this expression and saying they are equal to each other. The cost of 4 fancy water bottles is the same as the price of 2 fancy sporks. So I can make an equation now that shows the situation because I know they're equal. We haven't done anything where I've told you the amount before. So now I have an equation instead of an expression. That's how it works. Pretty simple. Let me do one more. So Biff found some money laying in the parking lot. There's a variable word right there, some money, right? Kind of already lets me know I have an unknown value or probably a variable coming up. Biff found some money laying in the parking lot, and he also got paid back $10 from his friend on the same day. He spent that money on a $14 mousetrap and a $1.50 candy bar. Write an equation that shows this situation. So again, I know some things that are equal, but let's talk about some expressions here. So expression number one. One expression I have is how much money Biff got. Separate from how much he spent, I do know how much money he got. So expression number one, I can say he found some money. I don't know how much. So we'll do maybe an M for money. And he got $10 on the same day. So the total amount of money that Biff has, I'm going to say is M plus $10. That's how much money he got. Expression number two is how much he spent. He spent $14 on the mousetrap and $1.50 on the candy bar. And so I don't have the word same or equal. I don't have a exact wording in here that lets me know they're equal, but it does sound like it to me, right? He says he spent that money. So to me it makes it sound like he spent all the money. So whatever money this is and whatever money this is sound to me like they're equal. So I can write them as an equation together. And what's neat about this one, with an expression, we never know how much money the variable stands for. But in an equation, you notice you probably, if you wanted, you could probably figure out what this was in this case. Right? If you stopped and thought about it for a while, you could probably figure out how much money he found in the parking lot, which would be neat. We're not going to bother with that yet today. We'll get to that in a little while. But I just want to show you that's how you make an equation. You take two different expressions, and if you know they're equal, something in the problem tells you they're the same, then you can make an equation. All right, open your math notebook. Let's do one together. I think just one. Yeah, just one. Wait, really? Yeah. All right. So you want to pause and write down the situation, you can, because you'll need the situation written down. And so here it is. So Gaitlin walked 2 laps around her neighborhood on Monday and 3 miles on Tuesday. So notice I have 2 separate things here. 2 laps around her neighborhood. Don't know how far that is. And 3 miles. I do know how far that is on Tuesday. Her mom drove 1 lap around the neighborhood and then 4.5 miles. They both traveled the same distance. Write an equation that models this situation. Alright, so let's talk about my info here. So expression 1, I'm going to make expression 1, just because it's in order, be how far Gaitlin walked. So she walked 2 laps around her neighborhood. I don't like L as a variable for lap. I don't know how far a lap is. L's, there's certain letters I don't like. L's kind of look like 1s. So I'll do N for neighborhood, 2 neighborhood laps. So we'll say she walked 2 times around her neighborhood on Monday and 3 miles on Tuesday. Don't need a variable there because I know how far she walked. I don't know how many miles it is around her neighborhood, but I do know if she just walked 3 miles, I can just write 3. So Gaitlin's walking is 2N plus 3 miles. And it just depends on this. We'll make mom be expression number 2. So mom drove 1 lap around the neighborhood. So it's the same neighborhood, right? So I used N to be the neighborhood here. And since it's the same neighborhood, I can use the same variable. I don't need to make a new variable because I know that this N and this N are the same. And then 4.5 miles. She went 1 neighborhood lap plus 4.5 miles. Okay. write an equation that shows this situation. So these two expressions, if we want to kind of put together, are going to make an equation. And we know they're the same distance, right? So we can say that they're equal. I can say whatever 2 laps around the neighborhood plus 3 miles is, however far that is, it's the same distance as 1 lap around the neighborhood plus 4.5 miles. And again, you might have a chance at figuring out the unknown value now. If you stopped and thought about it for a while, you might have a chance. Don't need you to do that today. Today, the plan was to make an equation that shows the situation, and we did. So hopefully that's a breeze for you. That's how you write an equation by setting 2 expressions equal to each other. Once you feel like you have a good handle on this, you've written down the problem and the good example here in your notes, you are all set, and I'll see you tomorrow.